Hey everyone, it's Chaz. Welcome back to the channel. And in this video, we're going to be looking at LeetCode problem 14, which is the longest common prefix. So let's dive right in. We'll read the problem first. It says, write a function to find the longest common prefix string amongst an array of strings. And if there is no common prefix, return an empty string. So looking at the first example here, we have a string array named stirs. I may just call it strings to make it easier on myself, but the array is named stirs and it contains the words flower, flow, and flight. And the problem is asking us, which letters do these words have in common from the start of each string? So in our case, flower, flow, and flight all contain FL at the start. And so we would output the letters FL. Looking at another example, here's dog, race car, and car. And in this case, you start at the beginning of the word, and these three strings have no letters in common. Even though car is at the end of race car, we're not concerned with the end of the string. We need to start at the very beginning. And because they have no letters in common, you would output nothing, output an empty string. And then just to give one more example, I have here cover, cove, and coverage. You can see that all three of these strings have the first four letters in common. And even though we can see that cover and coverage both have the R in common, it won't matter because cove doesn't contain that letter. It's missing from the second string. So we would only output cove, the first four letters. And this is important information to have because, as it turns out, the longest possible prefix that we can output as our answer cannot be longer than the shortest string in the array. Or to put it another way, if my shortest string is 4 letters, then my answer can't be more than 4 letters. 4 letters is the longest possible answer I could give. And that's going to be useful when we actually code this. So let's take a look at the constraints. First of all, stirs.length, or in other words, the number of strings that will be in this array, is going to be between 1 and 200, including those numbers. So that tells us there will be at least one string in the array. And that's going to be useful because when we're coding this, the algorithm that we use will work for any number of strings except for 0 strings. The way we're going to write it, it's not going to work if the array is empty. So because we know that we're not going to get an empty array, we don't have to code for it. And then the next constraint, stirs at I.length, or in other words, the length of any single string will be between 0 characters and 200 characters, including those values. So that means it is possible that one of the strings could be empty. And so we're going to have to account for that too, because when we're checking the characters in the strings, if there is no character in the string, that could cause a problem. So we're going to have to code for that. And then finally, stirs of I, or any individual string in the array, will consist of only lowercase English letters, so there will be no spaces, no numbers, and that's good because that means we don't have to code for that. All right, so let's take a look at the algorithm that we're going to use. We'll do it visually first. So step 1, I want to figure out which string is the shortest. So let's set up a box for a variable here, shortest string. And then we're going to go through each string one by one, starting with the first one, and determine if it's the shortest string we have seen so far. So checking the string cover first, it contains 5 letters. So far we haven't seen any strings, so it's automatically the shortest one. So we'll put it in the box. Go down to the next one, cove. Cove is only 4 letters. That's shorter than cover. 4 is less than 5. So that's our new shortest string. We'll just make that cove. And then check the last one. Coverage has 8 letters. 8 is not less than 4. So cove remains our shortest string. Next, we're going to check each string for a matching char, or a matching character. And they all must match. I must see the same character on every string. So we'll set up a box for our final output. And then we'll check the character at the first position. So we'll look at that very first character and we need to ask, do all the chars match? And if they do, if yes, add that character to the output string and then keep going. And if no, then the current output, whatever's in the box right now, is the answer. So in our case, the answer is yes. All the chars do match. So let's add a C to our output and let's keep going. So we're going to check the next character. So now we ask ourselves, in the case of the second character in each string, do all the chars match? And again, if yes, add it to the output, keep going. And if no, then the current output is the answer. So if no, we just output the letter C. So in our case, yes, they do match. So let's add the O to the final output and we'll keep going. Move on to the next character. So now we ask for the third character in each string, do all the chars match? In this case, it's yes again. So let's add a V to our output and we'll keep going. And now the question is, do these characters match? And yes, they do. So let's add an E to our output and then we'll keep going. Or wait, do we keep going? I mean, do we even have to check this? We said that the longest possible answer is going to be the same length as the shortest string. We already have an answer that's 4 letters long. The shortest string is 4 letters. So no, we don't even have to check these. So once we got a 4-letter output, we should just stop. Now I just want to go over the time complexity of our algorithm that we've seen so far. The time complexity is going to be big O of n times m, where n is the number of strings in the array, and then m is the length of the shortest string. And that's because we have to go through all of the strings one at a time to see which one is the shortest, and then we have to go through the characters in every string, but only up to the shortest one. And then one thing I also want to add is that the time complexity is linear with respect to the total characters across all the strings. So what I mean by that, when I look at the constraints and I see that the length of the array could be as many as 200 strings, and each of those strings can be as long as 200 characters. So in a worst case scenario, we're going to have to perform 200 times 200, that's 4 with 4 zeros. Wait, 40,000? Why am I so bad at this? Anyway, what I'm saying when I say the time complexity is linear with respect to the total characters is that if the shortest string, even if we have 200 strings, if the shortest string is 4 characters long, then we only need to check 4 characters. Even if all the strings were 2 million characters, but then one string is only 4 characters, we're only checking 4 characters. And then our space complexity is going to be O of 1, or constant space, and that's because we're going to store just a reference to the shortest string, and therefore no additional memory is going to be needed. So when we make our variable to find the shortest string, that variable will just be assigned to one of the strings that's already in the present array. So it's just going to be a reference to it. We're not going to copy that string to a new variable or to a new position in memory. So we're not going to need any extra memory. All right, so now we've explained our algorithm. There's only one thing left to do. Let's code some Java. We're not going to make that a thing. All right, so LeetCode gives us a class and it gives us the method itself, and I see that it will take a string array called stirs, and we also have to return a string. So the first thing I did in my code, and like I said before, you don't actually need to do this, but just for the sake of getting the code to run slightly faster in the case where there's only one string in the array, well, if there's only one string in the array, then there's no reason to be comparing characters. The entire string is just going to be the answer. So that's why I wrote here that if stirs.length is equal to exactly 1, or if the number of strings in the array is equal to 1, just return the first string. Now the next part of my code is where we iterate through all the strings in order to find the shortest string. So first of all, we'll set up a variable with a string data type. We're going to name it shortest string. And for now, we'll just assign it to the very first string in the array. And then we're going to use a for loop, but this isn't the for loop that we used in the last video. This is what is known as an enhanced for loop. So the main difference is that a traditional for loop has 3 parts: the initialization, the condition, and an update. You're going to use that mainly when you know in advance how many times you want your code to run, or you're going to be doing something to those values in the array. And it's also useful when you actually need to know what is in each position, the specific positions of the array. With an enhanced for loop, that's going to be a little different. We use an enhanced for loop mainly when you don't care what the index of each value is, and you don't plan on modifying each element in the array. So in our case, we're definitely not going to change the strings. So we're not modifying anything. And when we figure out the shortest string, I actually don't care what index it's in. All I care about is which string is the shortest. Because of that, we're going to use this enhanced for loop because it's a lot easier to read. So the way it works is I just set up a variable with a string data type. I name it current string. And the way you read this is you say for string, current string in strs. So it's going to check each string in that strs array. Going to check every single one of them. And then we have our if statement, and the condition here is if current string dot length is less than shortest string dot length, or if the length of the current string we're looking at is shorter than the shortest one we found so far, then we're going to assign that variable shortest string to be the current string. So like in our example here, we saw that cove was shorter than cover. So the length of cove is less than the length of cover. So my shortest string becomes cove. Now that we know which string is the shortest, we need to deal with an edge case where that shortest string happens to be blank. And so actually, hang on. I'm thinking about it now, and we actually don't need this edge case. But it does. We'll just talk about it anyway. So this is another optional situation. Then I just realized we don't actually, the way our code is going to run, we don't need to include this line. But just to take a look, if the shortest string's length is 0, if the shortest string turned out to be blank, we can just immediately return a blank string, just output nothing. It turns out our code will do this even without this line. So I added this little part just reminding us that one of the strings could be empty, but thinking about it now, we don't even need this line. So let's move ahead. We're going to loop through each char at location in each string. So in other words, we're going to start at the first character of every string and move forward. So we have a regular for loop this time. So we have a variable I started at 0. We're going to go from 0 to the length of the shortest string. So if the shortest string is 4, then we're going to go to index 3 because that would be the last character of the shortest string. And then I++, because we're going to go 0, 1, 2, 3, etc. We're going to increase the value of I. We create a variable here. It's going to be a char data type, and we name it test. And that's just going to be the current character in the first string. I just need a test value to test the rest of the strings. So I just do strs of 0, the very first string in the array, char at I. So when I starts off at 0, it just means char at 0. We're checking the first character. And then as the for loop continues, we're going to check each successive character. So I wrote some comments to explain what we're doing. We're checking the rest of the strings to see if they have the same character. So like in this example, starting at I equals 0, the test character is the letter C. And so I'm going to check if the rest of the strings also have a C. And then if there's a mismatch, we're just going to return whatever's in the box. So if no, the current output is the answer. And if it matches, we just add it to the output and move on. Or in our case, we're actually just going to do nothing. We're going to wait until we find a mismatch. And then if we don't find a mismatch, so if the answer to this question is always yes, no matter what, we'll add an extra line of code to deal with that at the end. So how do I implement this? Well, I use another enhanced for loop. So for string y in strings, so this time it's just the letter y is going to represent each string in the array. So my code here says if y.char at I is not equal to test, or in other words, if the character I'm checking in each string is not the test character, in our example, if it's not the letter C, then we just return whatever's in the box right now. So return shortest string dot substring, which will just be a segment of the shortest string from index 0 to whatever I is right now. So like if we're checking the first character, I is 0, so it would be substring 0, 0. Now, the way substring works is it'll take a segment of that string from the first number you give it to the second number, but not including the second one. So if I have the string coverage, if I use this bottom one as an example, substring 0, 4 would just be the first 4 letters of coverage. It would just be cove. And the way I think of it, like if I have 0, 4, it's like I'm saying start at 0 and the substring is going to be 4 characters long. That's how I think of it. When I see like 0, 10, it means start at the beginning and it's going to be 10 characters long. Or, you know, if I had substring 10, 15, it would mean start at character 10 and then 15 minus 10 is 5. So I know that my actual substring is going to be 5 characters long. So that's just a shortcut way of thinking about it. But if you want to be proper about it, you're just saying that the substring should start at the first number and then go up to the second number, but don't include it. Now, I want to go back to the beginning of the outer for loop. We said earlier that the longest possible output can only be as long as the shortest string. And that's why this for loop stops when we reach the length of the shortest string. Because our inner for loop only deals with the situation where the character doesn't match, we need to still do something for when all of the characters matched all the way until you reach the end of the shortest string. So like in our example with cover, cove, and coverage, there was always a match. The answer was always yes. And so when we reached the end of the shortest string, cove, it turned out that the entire string cove was the answer. So we're going to do that at the end of our code. If the loop survives, then the entire shortest string is the answer. So simply return shortest string. All right, so here's our final code on the screen if you want to pause and take a look at the whole thing. When I hit submit on this code, it should work. And yes, it does. And it does pretty well on memory, does pretty well on runtime. I would say on LeetCode, don't trust the memory value. It tends to be all over the place. It's really the runtime that matters. So that's going to be it for this video. I've been really bad at remembering to say this, so just bear with me for a second while I try to get through it. Like the video, share it if you know somebody who might be interested in it. Subscribe. What did I miss? Make a comment. It helps with engagement. Why am I so bad at this part? Lucky, why am I so bad at this? Hey, baby boy. Anyway, that's it for this video, and we will see you next time. Right, Lucky? And because of that, I just want to add an additional point that the time complexity is linear with respect to... The hell is that?